Autophagy is often portrayed as a binary process, either on during fasting or off during feeding. But in reality, it behaves more like a dimmer switch than a light switch, subtly adjusting its activity based on hormonal signals, nutrient levels, and energy demands. This nuance is especially relevant when we consider the impact of slow-burning carbohydrates, like legumes, barley, oats, and certain root vegetables, on cellular repair. Unlike high glycemic carbs that spike insulin and rapidly shut down autophagy, these foods digest slowly, releasing glucose at a gentle, sustained pace that allows for a remarkable metabolic compromise. Nourishment without complete interruption of cellular renewal. When we eat foods that release glucose slowly, the insulin response is significantly muted. Instead of triggering a sharp hormonal cascade that activates mTOR and suppresses autophagy entirely, these carbs maintain a low and steady postprandial state. This matters because insulin is one of the primary inhibitors of autophagy. By keeping insulin modest, slow-digesting carbs permit a state of metabolic middle ground, where cells continue to receive fuel, but not in amounts that override internal sensing systems like AMPK, the enzyme that signals energy scarcity and helps activate autophagy. In this semi-fasted biochemical environment, autophagy doesn't shut down entirely, it simply downshifts. It may not operate at the intensity seen during deep fasting, but it remains active enough to continue clearing minor cellular debris, supporting mitochondrial quality control, and regulating inflammation. This is particularly beneficial for tissues like the gut, liver, and brain, which thrive under stable energy availability and suffer under sharp metabolic swings. In this way, slow-burning carbs promote a form of gentle cellular maintenance, a low-flame autophagy that quietly sustains intracellular health even during daytime meals. Legumes are a powerful example. Rich in resistant starch, fiber, and plant-based protein, they digest over hours, keeping glycemic variability to a minimum. At the same time, their fermentation in the colon produces short-chain fatty acids like butyrate, which independently stimulate autophagy in intestinal cells. Barley offers similar advantages, with its high beta-glucan content slowing digestion and modulating the insulin response. Both foods nourish the microbiome, generate postbiotic metabolites, and support tight junction integrity in the gut, all of which are linked to autophagy-driven renewal. This pattern of metabolic steadiness also helps prevent the kind of nutrient overload that overwhelms autophagic pathways. Frequent high glycemic meals create a cellular environment of surplus, excess glucose, constant insulin, suppressed recycling. In contrast, a diet anchored by low glycemic carbs promotes homeostasis. Nutrient-sensing pathways like AMPK, SIRT1, and even certain circadian genes remain active, signaling the cell to balance fuel use with ongoing maintenance. Over time, this translates into better mitochondrial function, lower oxidative stress, and slower biological aging. Perhaps most intriguingly, this steady-state approach to autophagy may be more sustainable for many people than aggressive fasting or extreme carbohydrate restriction. Rather than requiring long periods of abstention, it invites a daily rhythm of mild activation, restorative rather than depleting. It allows the body to enter a state of fed repair, especially when meals are composed of whole, fibrous carbohydrates that mimic fasting signaling without its discomfort. It's a way of living that respects the body's need for energy while still honoring its requirement for internal housekeeping. This model may also explain why populations consuming traditional diets rich in slow-burning carbs, such as lentils in South Asia, barley in Mediterranean cultures, or sweet potatoes in Okinawa, experience remarkable longevity and low rates of metabolic disease. These diets are not low-carb, but they are metabolically balanced. They keep glucose curves smooth, insulin exposure minimal, and inflammatory signals subdued, which collectively fosters a cellular terrain where low-grade autophagy can persist throughout the day. In this light, the choice of carbohydrates is not simply about calories or macros, it's about information. Slow-burning carbs deliver a message of stability to the cell. No crisis, no overload, no need to shut down repair. They allow autophagy to hum in the background, maintaining order without drama. This metabolic quietness may be one of the most underappreciated advantages of whole food carbs. They give the body energy to live and just enough cellular space to renew.